So how many moves does it take to move n disks? What is the total running time of this recursive algorithm? Well, let's call that function f. So let's say f of n is the total number of moves we need to move n disks. F of 0 is 0, because it takes no moves to move no disks. But the structure of this recursive program lets us write down an equation for f, what we call a recurrence relation. In order to move n disks, we need to move n minus 1, and then make one additional move for that largest disk, and then move the n minus 1 disks again. So f of n is twice f of n minus 1 plus one more. With this base case and this equation, we can just compute f of n for the first few values of n. And for instance, what I showed you before is that with 7 moves, we can move 3 disks. Well, let's see. How many moves will it take to move 64 disks? Possibly quite a lot. Here is your next quiz. I want you to take this equation for f, along with the base case that f of 0 is 0, and try to figure out the general formula of what f of n is as a function of n. Let me give you a hint. You can tell that because I have to move n minus 1 disks twice in order to move n disks, that roughly speaking this function is doubling every time. So maybe f of n is roughly 2 to the n, perhaps 2 to the n times something, or 2 to the n plus or minus something. Play with it a little. Try plugging in different functions into this equation and just experiment and see if they work or not.